known as interrupt vector table, right? So that is what we will be needing today, at least the interrupt vector table. That is something which will require in today's class. Okay. Okay. So on the right bottom side, you can see that this is the interrupt vector table. Are you hearing me?
Yes, sir.
Okay. So on the bottom right side, you are seeing the interrupt vector table. So these are your addresses where your new C is supposed to jump if any of these interrupts are invoked. Now, try to recall something. Whenever we wrote our programs so far, our programs were something like this. We started with origin 008 and we had our programs, right? So all the programs we wrote over there and finally we ended. So what does this thing mean? It means that you are starting from ROM location 00 and gradually you are going. That does mean that so far all the programs that you have written, actually you overwrote in these memory addresses, right? Because when you're starting the program, it will start from 00, it will keep on going. At some stage you will reach this address, you will reach this address. So you will overwrite in all these ROM addresses, which we are not supposed to do, isn't it? Because we know that from the interrupt vector table that these are the memory locations which are set aside for these interrupts. For all the interrupts that we have got certain memory locations which are set aside for these interrupts. But we did not consider all these things so far in this course. Whatever program we have written so far, we overwrote in all these memory locations. But we saw that we did not face any problem. Even in our lab also, we simulated some of the things, like we simulated writing something in the LCD, then we went for keyboard interfacing and all those things. Every time we started with origin 00H, but we never faced any problem. So what actually happened is this point. Because of this, we did not face any problem. Upon reset, all our interrupts are disabled. And in our previous program also, we never required any interrupt. So that's why even if you write on these memory locations, it does not matter because you are not going to invoke an interrupt. Since you are not going to invoke any interrupt, you can overwrite in all these addresses. But in this chapter, now we are dealing with interrupts. That does mean you should not touch these memory locations. These memory locations should be set aside only for the interrupts. So how can we bypass this thing? So one simple way to bypass this thing is like this. You start with origin 0h, no problem. But your first instruction will be this. Long jump main. Okay. You go to a safe address, say origin 30h, and you start from here. So this is your main. You write your codes and you finally end it. So in this chapter, you will see that all the codes that we see, it will start in this fashion. It will have a long jump main, and your main will start from a safe address, which is quite far beyond the addresses which are set aside for the interrupts. So is this point understood to all of you? Up to this, have you understood? So if you say nothing, I will assume that you understood. Moving forward. Now, a register IE is responsible for enabling and disabling the interrupts. So this is an 8-bit register. We will discuss in details about this register just after this page. So we have a register, 8-bit register. The name of the register is IE, which is interrupt enable. So this register actually is responsible, or it controls the function of all the interrupts. I mean, you can activate or enable or disable any interrupt using this register, that is IE register. And the most important thing is this register is bit addressable. So you can access separate bits of this register separately, no problem with that. Yeah. So if you do not have any question, I'm moving forward to discuss about the IE register. I don't think you need to draw this figure because the exact same figure is supposed to be there in your book. It is supposed to be figure 11.2. You can, while I draw the figure, you can just cross check whether you have got the exact same figure or not. If it is the exact same figure, I don't think you need to write. Alright then. So this is your IE register, all the 8 bits. We are not interested in bit number 6 and in bit number 5 because bit number 6 is actually reserved for future use. So we don't have to deal with it. And bit number 5 deals with timer 2 overflow. But recall that we in our 8051 MUSI, we only have 2 timers, which are timer 0 and timer 1. We don't have a timer 2. So that's why it is specifically for 8052. Now, the rest of the bits are of importance to us, and you can gradually see that bit number 4 controls the serial port interrupt, bit number 3 controls the timer flow interrupt, and all these things. Now, how do we enable or disable any interrupt? The first thing first, in order to enable any interrupt, your EA must be 1. If EA is 1, then controlling rest of these bits, as you can see in the IE register, you can enable and disable the respective interrupts. But if EA is 0, then doesn't matter what you write in rest of the bits of the IE register, all your interrupts will be disabled because EA is equal to 0, and upon reset by default EA is always equal to 0. So we need to make sure EA is 1. Now let us assume that you want to enable EX1. Say you want to enable this particular interrupt. So what you have to write is, you have to make sure EA is 1. All the rest of the bits are 0 except EX1, like this. So if this is the value which is fetched to the IE register, then your EX1 or this particular interrupt will be enabled. Is it understood to all of you, whatever I'm trying to say?
Yes, sir.
In the next one, I will ask someone randomly based on whatever I have just taught you. So if you can't answer, it will have a negative impact, okay? So I don't want that to happen. So again, I'm asking, if there is any question in this page, please ask. Okay, so let's move on.
Sir, suppose if EA is 0 and EX1 is 1, so this instruction won't work.
Right, it will not work. For the rest of the bits to work, your EA must always be 1. Okay? Moving on, as I said, we'll take an example which will make the concept, whatever we are learning, it will be clear. Still, the question is, we want to enable ET1, EX, and EX0. So this is the first question. The second question is, say, disable ET1. And the third question is, disable all the interrupts. Okay. So let me ask someone of you to give me the solution. Of course, I will help you in finding the solution. Okay, how about ID 1061? Tanmay. ID 1061, can you hear me?
Yes, sir.
Alright. So the first one, the question is, we need to enable these 3 interrupts, okay? ET1, ES, and EX0. So definitely your instruction will be something like this: move IE, hashtag. Then can you tell me what is the value? What will be the value to activate these 3 interrupts?
Sir, 1.
Okay, then.
Sir, 10111.
111.
Yes, sir.
111. Then
I'm not sure though.
why are you not sure? You tell me. Let me go back to this page. Which portion did you not understand? Tell me. This is a very simple question.
Yes, sir.
So now tell me, what is the value?
স্যার একটু আবার চেক করতে পারি স্যার, মানে তখন তো স্যার উঠাইতেছিলাম স্যার, মানে এই
এটা
জন্য
বইয়ে
কনফিউশন
আছে, এটা বইয়েই আছে তো। It is there in your book.
জি স্যার।
Okay, look at this figure. That tell me.
স্যার 101।
Yeah, 101. Then
স্যার
Finish.
1001 1001
1001. Then
1001।
are you sure this is the instruction?
স্যার স্যার আমার কাছে এটাই মনে হচ্ছে স্যার।
Okay. Why did you think this is the instruction? You tell me that. Give me the explanation. Why did you think that these are the? I mean, this is where 1 is supposed to be there. This is 0, 0, 1. Why did you do like this? Tell me. Let's start with the first one. Why is the first one 1?
স্যার
You can say in Bengali. Doesn't matter. Tell me why the first bit is 1. Tell me.
Sir, EA needs to be 1, sir. That's why.
All right. EA needs to be 1. Okay. Then why is this bit 1? The next one. Why is this 1?
Sir, I'm not sure, sir, on that.
Okay. So let's ask someone. So what I'm assuming, someone or some of your friends gave you the answer and you just told me that.
No, sir.
If,
Sir, আপনি তো আগের পেজে দেখাইছিলেন স্যার, তো ওটা
if that is not the case, then you yourself gave me the answer and now you yourself don't know why you made this bits 1. Then tell me, what should I think? আমি আগের পেজ আবার দেখাচ্ছি, you can
জি স্যার, বুঝতে পারছি আপনার। ঠিক আছে স্যার।
বলতে পারবা কেন 1 করছে ওই জায়গাগুলো?
স্যার ইএস এর জন্য স্যার সেকেন্ড বিট স্যার।
স্যার ইএস এর জন্য সেকেন্ড
বিট 1 স্যার।
আচ্ছা, এটাকে অ্যাক্টিভেট করতে I mean we have to enable ES, that's why that is 1. Okay.
Yes.
Why the next one?
স্যার ET1 এর জন্য স্যার 1 স্যার।
So this is the explanation I wanted to hear. So we need to make sure that these 3 interrupts are enabled. That's why the corresponding bits in the IE register for these 3 interrupts are made 1. And as master, EA is always 1, right?
Yes, sir.
So this is the explanation I wanted to hear. Okay. So let me go for the next question too. 1016.
Yes, sir.
So can you give me the solution of the next one? To disable ET1, what should be my instruction?
To disable ET1. Then, sir, 1000 0. I mean, sorry. 1000 then 0 81 then EX then 0 which is on.
I can go to the previous page if you want.
Yes, sir. ET1 okay, sir, and then 10 then 0 then 1 then 0 0 0 1.
কয়টা বিট হলো? আই রেজিস্টার তো 8 বিট।
জি স্যার, আপনি আগে গুলা প্রবলি ইয়া করেন।
আচ্ছা, আবার বলা যেত আমি কাটলাম আবার।
তবে স্যার ET1 ওকে স্যার হবে হচ্ছে 10 then 0 1 then 0 Then 0, 0, 1.
Okay, so this is the value which should be fed to IE. Okay. Is there anyone who thinks the answer, or there might be a different answer? Anyone? The floor is open. Anyone can answer. So we can write what? Clear then. Look at the previous figure. Clear then. Okay, then. Okay, so clear IE dot 3. All right. This is actually the correct solution and not this. Okay, let me just tell you why. Because when you are given the question disable ET1, you are told nothing about the rest of the interrupts. Okay, you don't know anything about rest of the interrupts.
Okay, sir.
So since no, it's okay. I'm not saying that you gave a wrong answer. From your point of view, it is okay. I mean, from your stage, it is correct. Your logic is correct. But now try to think in a different way. Okay, when you are asked to disable an interrupt, since you are not given the information about rest of the interrupts, you will not touch the rest of the interrupts. It might happen that all of the interrupts are high, okay? But see, in this instruction, what you are doing, you are enabling all the registers. I mean, that is fine. EA is high. Then you are making sure that these two registers, I mean, these two interrupts are also enabled. But you are told nothing about these two interrupts in this particular question. Your only question is you need to disable ET1 irrespective of the status of the rest of the interrupts. So your simple instruction will be clear IE.3 so that you don't touch the rest of the interrupts. And as we already know, IE is bit addressable. So if you can find the solution in a bit addressable manner, you will never approach your byte addressable way. Okay? You should always go for bit addressable solution. So the last one, disable all the interrupts. I think this should be easy. Anyone can answer. What should be the instruction?
Clear IE.7.
Exactly, clear IE.7. So this is very simple. We don't need to worry about this. So clear IE.7 will clear all of the bits, right? Okay. So you see, for the first one, instead of writing this, a more appropriate approach would have been something like this. That is to access it separately. So first of all, set bit IE.7, then set bit IE dot just see the value of ET1. So your ET1 is IE.3. So set bit IE.3, then set bit IE dot for ES is 4. So dot 4 and set bit IE dot EX0. I think EX0 is 0, right? So this would have been a better solution to question 1, but this is also okay. Is it clear up to this, everyone?
Yes, sir.
All right. So let's move forward. All right. Now we will go for programming timer interrupts. Now, in order to clearly understand this portion, you will need a lot of information from chapter 9. But unfortunately, we discussed chapter 9 before it. We had a long gap, and we also did not have any quiz on chapter 9. So I'm guessing 90% of you don't remember anything of chapter 9, right? So মনে আছে কারো চ্যাপ্টার 9 এ কি পড়ছিলাম না পড়ছিলাম? না। আচ্ছা ঠিক আছে। Those who are sitting with class notes, at least you can correlate, and those who are just laying on your beds, try to recall. I know you'll not be able to recall, but just try to recall. And if you have your class note, just try to turn your pages when I say something related to that. Okay. So let us start. Programming timer interrupts. In chapter 9, whenever we started a timer, the next thing we did was something like this. And this was the example I gave in the previous class as well. Jump not bit TF, say if the label is again, then this is again. And I told you this is an example of polling. Do you at least remember this portion?
Yes, sir.
So trying to summarize what happens. When you start a timer, then your TF flag monitors the state of the timer, or TF flag signifies whether the timer operation has been finished or not. By default, the value of the TF, it can be TF1 or TF0, okay? So by default, the value of TF is 0. When your timer operation is done, then your TF becomes 1, and that is when we understand that our timer operation has completed. So using this line, your MuC continuously monitors whether TF becomes 1 or not. But you see that this is a wastage of your MuC's capability, because your TF will become 1. So by the time TF becomes 1, your MuC can engage itself in doing some other things, provided TF will be smart enough to inform the MuC when it becomes 1. So this is exactly what happens when you enable ET0 and ET1. These are your two timer overflow interrupts. So your TF0 can send a signal to ET0, and your TF1 can send a signal to ET1. In simple language, if TF0 becomes 1, then it can invoke the timer 0 interrupt, and if TF1 becomes 1, it can invoke timer 1 interrupt. That means normally the value of TF0 is 0, but if TF value becomes 1, it will invoke the ET0 interrupt, or timer 0 overflow interrupt. So if that interrupt is invoked, then your MuC will jump to a particular address. Can you tell me in which address it will jump?
Sir, 000B.
Right, 000BH. I know that I have talked a lot of things during the past 2 or 3 minutes, and it was quite difficult for a lot of you people to pay attention, but those who could pay attention, I mean, good, thank you for that. Okay. All right, so I'm summarizing again. So our TF flag becomes 1 whenever your timing operation is finished. So if you enable this interrupts, that is ET0 and ET1, say ET0 is enabled. So if ET0 is enabled, whenever your TF0 becomes 1, it invokes the ET0 interrupt. Invoking the ET0 interrupt means your MuC will jump to this particular address. So if you have understood whatever I just repeated, tell me something. If TF becomes 1, then your MuC will jump to which particular address? It will jump to which address?
So
001B.
Right, 001BH. Thank you. So that means provided that these interrupts are enabled. So if these interrupts are enabled, your TF or timer overflow flag will automatically invoke the respective interrupts. That gives your MuC the liberty of not having this instruction. So during this time, your MuC can get engaged in doing some other work. So let us take an example, the first example in this chapter. I think that will make it very clear. The other sections told me that this is the exact same example of your book as example 11.2. So you can just cross check. If it is indeed the same example, definitely you don't need to write. Okay, you can just cross-check and pay attention. But so I need to write the question to explain this. Okay, so this is the question. Before we go to the solution, there are a few things we should make clear. Okay. Now, first of all, try to find out that in this program, your mu C is executing how many tasks. So some of you might answer 2, some of you might answer 3, both of which are correct. So if you think mu C is doing 3 tasks, that means one of the tasks is displaying a value of y at port 0. Another task is displaying the value of n at port 2 and generating a square wave of 10 kilohertz. Or you might combine the previous 2 tasks together, like displaying a value of y at port 0 and n at port 2, because these two belong to the same class of problem. But this one is a different category of problem. So it actually does 2 things, okay? So that is the first thing we need to understand. Now these are definitely independent of each other. That means you need to execute both of the tasks at the same time. All right. As I said, to understand this portion, you need to have the knowledge of, you need to recall some of the knowledge of chapter 9. Because we have got 2 things over here, that is timer 0 and mode 2. So let us go one by one. So try to recall how many registers are there for timer 0. Can anyone tell me how many registers are there for timer 0? Or timer 0, what is the size of timer 0 register? How many bits?
8.
Timer 0 is actually 16-bit register. So those 16-bit register has got 2 names. Can you recall the names?
So
T, koto T.
TLO and THO.
Exactly, very good. So the 2 registers are THO and TLO. So these are the 2 8-bit registers which are allocated for timer 0. All right. Now, can anyone recall what is mode 2? Mode 2 is, okay, let me say, mode 2 is 8-bit auto reload. Okay. So mode 2 is 8-bit auto reload. That means we will load the required value in TH0 and then TL0 will get a copy of the value that we loaded in TH0. I'm repeating again, whatever is our required value, we will load that value in TH0 and TL0 will get a copy of that exact same value. Then when you start the timer, your TL0 will take part in that timer. Okay, it will keep on going. Whenever it will roll over from FF to 0, again it will get the value of TH0 and again it will start the timer. So that's why it is known as auto reload. Okay, having said all these things, now we need to create a square wave of 10 kilohertz. So if we need to create a square wave of 10 kilohertz, what is the first step? What is the first thing that we need to do to find out the value which is to be loaded in TH0? The question is, generate a square wave of 10 kilohertz. You are given the frequency. Now you need to find the value that is to be loaded in TH0. So what is the first step? Can anyone tell me? কারো মনে নাই? ফ্রিকোয়েন্সি দেওয়া থাকলে প্রথমে কি করতে হয়? হ্যাঁ, আবার
The loop.
Loop will come, not loop, yeah, loop will come a little bit later. But before that, what do you need to do? From frequency, what do we have to find out?
Sir, একটা মেশিন সাইকেলের জন্য কত টাইম লাগে?
Right. For 22 megahertz, we know that this is 0.546 microsecond, right? Assume we calculated that already. We know that one machine cycle will require 0.546 microsecond. Then, from the frequency, what do we need to find out?
Sir, এত
মনে নাই? The first thing we need to find out is time period, right? Because we are given the frequency, you need to convert that to time. Otherwise, how will you calculate? From frequency, you will go to time, you will find the time period. From time period, you will find the number of cycles that are to be executed, isn't it? That was the basic summary. Okay, so tell me, T is equal to 1 over F. So what is my time period? The frequency is 10 kilohertz. So tell me, what is the time period?
So 10 to the power minus 4.
Okay, so we can write 100 microsecond, right?
Yes, sir.
All right. What is the next step? Let's see. Now, can you recall what should be the next step? You have found out the time period. Then, what is the next step? See, try to see the output in P2, P1.2 will be something like this. Square wave of 10 kilohertz, right? So it will be something like this. So which is your time period? This is your time period, which you already found out to be 100 seconds. What is the next thing that you have to calculate?
So 22 megahertz, sir. 12 by 22 megahertz করতে হবে.
That is for finding one machine cycle. Okay, assume it has already been calculated. That is 0.546 microseconds. Now I'm saying you have found out the time period. Then what is the next thing you need?
So divide the time period by 2.
Exactly, that is what I was looking for. Why? Because this is the delay. This much portion is the delay that you will create using your. I think time period is bhul aapko. Just a second. Time period aisa bolna. Yeah, time period is this one. Yeah. So now you have to find out the delay because that is what you will design. So your delay will be time period by 2, which will become 50 microseconds, right? So now you know your delay. So if you know your delay, what is the next thing? You need to find how many cycles we need. How can we find the number of cycles? সব ভুলে গেছো 50 microsecond divided by 1 machine cycle, that is 0.546 microsecond. So 50 divided by 0.546 will give you around say 92. So 92 cycles. So if we need 92 cycles, the last step is, since it is a 8-bit auto reload in mode 2, we need to subtract it from 256. I don't know whether you remember or not. But if I keep asking, the class will not finish. So I need to finish it. 164. So convert this 164 into hex. We will get 0A4H. So that is the value that we need to store in TH0 for generating 10 kilohertz with timer 0 in mode 2. Remember, in your exam, you have to show all these calculations, okay, in order to justify your answer. So let me give the solution, then I'll explain the rest of the code. So this is the entire solution. So let me explain the code. So origin 00H is very simple. We start from there. We already explained why we go to long jump. So we directly come over here. Long jump main. Then we write move tmod, 0 to h. This is again from your chapter 9. Why you are moving 0 to h to tmod? Because we are selecting mode 2 and timer 0. So for selecting mode 2 and timer 0, the value which is to be loaded in tmod is 0 to h. You can check from chapter 9 to verify this thing. Then we move T80 0A4H. This is from where we got the value from all these calculations. Then we move 82H to IE. While we move 82H to IE, if you convert this 82H to binary, you will see that this is the value we need to give in the IE register to enable EA and ET0. So we need to enable ET0 and EA. So that's why we are moving the value 82H to IE. Then we start the timer. Set bit TR0. Recall from chapter 9. This instruction set bit TR0 will start your timer. After that, we enter to another loop, which is back move P10. So these two is actually performing this task and this task indefinitely. Then short jump back. So you are indefinitely performing these two tasks. In the meantime, keep in mind you have started your timer. That means whenever your TF0 becomes 1, your MUSE will jump to which address? It will jump to 000B. That is this address 000B. So assume your MUSE is in this particular line. Just for simplicity, let us assume your MUSE is executing this particular instruction. In such moment, your TF0 became 1. That means your ET0 has been invoked. So what will your MUSE do? Your MUSE will complete this task. Okay, it will complete this task and it will save the address of the next instruction onto the stack. I repeat again. Say your MUSE is in this particular line, that is move P0, #Y. In such a moment, the ET0 interrupt has been invoked. So what your MUSE will do, it will finish this task and it will save the address of the next instruction onto the stack. After saving the address onto the stack, your MUSE will directly come over here. It will directly jump to this particular address as we have already seen from the vector table. Then it will complement and whatever it has to do, it will do. After that, this instruction return I is equivalent to a pop instruction. This was also discussed in our previous class. So what is the function of this pop instruction? Whatever address was pushed onto the stack by the MUSE, that address will be popped out. So since that address will be popped out, your MUSE will understand where it needs to get back. So from the popped out address, your MUSE will understand that it needs to get back to this particular instruction and your MUSE will start working in this loop again. Is it understood to all of you? I know I should not say all of you, but those who are paying attention, have you understood?
Sir, complement port 1.2, sir.
Complement port 1.2, huh?
Sir, এই লাইনটার মানে কিয়াটা কি কাজটা কি?
Acha, acha. So this is the output from P1.2. This is the output that you are supposed to expect. So, okay, yeah. All right. Now I was expecting another question, and that question would have been raised if you read chapter 9 properly, which is okay. The other thing is, if you remember chapter 9, you should know that whenever TF0 became 1, we manually made sure that your TF0 becomes 0 once again, because in mode 2, this is 8-bit auto reload. That means once this counting by TL0 is over, it will again get a copy of TH0 and again it will start counting. So if TF0 remains 1, how will it give the signal for the next instruction? That's why every time TF0 become 1, we had to make sure that there is a corresponding instruction that makes TF0 0. But see, in this particular code, there is no such instruction. This is because this TF0 invokes ET0. So whenever TF0 invokes ET0, your mu-c internally clears the TF0 so that it becomes ready for the next cycle. After clearing, it invokes this ET0, your mu-c does all these things. But before all these things, TF0 is internally cleared by the mu-c. So you don't have to worry about TF0. So what is the main advantage over here? The main advantage is after starting the timer, you can engage your mu-c in doing any other work as required. Then whenever your timing operation will be over, your TF0 or TF1 that will invoke the corresponding interrupt, and your mu-c can get back and do whatever it needs to do for that particular interrupt and get back to whatever it was doing. Is it understood?
Yes, sir.
All right, so this was for mode 2. So what will happen if we have mode 1? That is the question. Because mode 1 is not auto reload. Okay, we need to load the values in TH and TL once again in mode 1. So what will happen if we have mode 1? The answer of this you will find in example 11.3, which is also very, very easy. But if I had started with 11.3, it would have been a bit complicated for me. So that's why I started with 11.2. If you have understood this example, then understanding 11.3 will not be any problem at all. So please, when you get time, just go through example 11.3. And if you face any difficulty, of course, I will explain it. I will explain it again in the class. Doesn't matter. Okay, so we will pause over here. So up to this, if there is anything that you did not understand, you can ask.
Sir, can you repeat the part of minus 256 minus 92? Why did you minus from?
Okay. Had we been in mode 1, after finding the cycles, what did we do? We subtracted from 65536, right? This was
Yes.
the last step. Do you remember? Or in hexadecimal format, we subtracted minus the equivalent of 92, then we added an 1, right? This is how we found out in hexadecimal format.
Yes,
but in decimal, we found out this. But since we are in mode 2, your mode 1 is 16-bit. Right? Mode 1 is 16-bit. That's why you subtracted from 65536. But our mode 2 is 8-bit. That's why we subtract from 256 minus the value. Or if you, this is FFF. Or if you go in decimal, hexadecimal, it will be FF minus XX plus 1. Just see chapter 9. It is, all of these things has been discussed. Just see chapter 9, you will understand.
Okay, sir.
Right?
Sir,
Anything else?
স্যার মোড 2 এর যে অটো রিলোডের পার্টটা স্যার ওইটার ইম্পর্টেন্সটা কি স্যার এখানে
এখানে the importance over here is, since it is auto reload, you don't need to load these values again. See, once you have started the code, you are always in this loop. You are always in this loop. Sometimes you come out and you are engaged in this loop. So you are switching back and forth between these two loops. You never come back to this loop, right? Isn't it?
Yes,
This
sir.
is simply because this is auto reload. If it were not auto reload, then every time you finish the counting, you had to make sure that you come to this line. So that's what you will see in example 11.3. If it is not auto reload, then you need to repeatedly come back and load the values in TH and TL again. Is it okay?
জি স্যার
Any other question? আর কারো কোনো কোশ্চেন নাই? Alright, so if there is no other question, let me just take your attendance, and after that I will let you leave. Second. You guys are section 3, right? I think 4 of you are absent. So can you look for your corresponding student ID?